Let's do this problem right here. The question is asking, let V1 and V2 be a basis of subspaces, and they are asking to find whether V1 and V2 are linearly independent. So to find this one, the first thing we have to do is we have to do the Gauss theorem. To do the Gauss theorem, I have to arrange this into rows. So for this one is going to be V1 is going to be 1 0 1 1 right here, and V2 is going to be 3 0 1 minus 1. And now I have to do the Gauss theorem. So in order to do the Gauss theorem, I have to make this one 0. To do that, I can multiply the first equation by -3 and add it to the second equation. So if I do that, I will get 1 0 1 1 and minus 3 r1 plus r2. So this will give us 0 right here, and 0 minus 3 plus 1 is going to be minus 2, then minus 3 plus 1 is going to be minus 3 minus 1 is going to be minus 4. So now we have done the first thing, and the second one is the second thing we can do. We have to simplify this one into symbol format. So we want 1 in the pivot, right? So in this case, what I have to do is I can divide this one by -2. So this will become 1 0 1 1, and the bottom part is going to become 0 0. And if I divide this row by -2, this will become 1, and this will become 2. So I am dividing this r2 divided by -2. Then I have to make whatever the value above pivot equal to 0. So in this case, I have to make this one 0. To do that, I can multiply the second row by -1 and add it to the first row. So if I do that, I will get 1 0. So I'm doing -r2 plus r1. So 1 0 0 -2 plus -2 plus 1 is going to be -1 over 0 0. So this is okay. 0 0 1 2. Now we brought to the full Gauss theorem pattern. So from this one we can say whether it's linearly independent or not. If you see the basis, this basis has 2 pivots and 2 vectors. So that's one of the factor determines this is linearly independent. So these 2 vectors are linearly independent, since we have number of vectors equal to number of pivots. Therefore, these vectors are linearly independent. Also they are not scalar multiplication of each other, so we can mention that too. These vectors are not scalar multiplication of each other. So these 2 things we can say when we say this is linearly independent. The second thing is they're asking to find the orthogonal basis of S. So in this case, what I can do is let's consider W1, W2, 2 orthogonal vectors. So I take the V1 as W1, V1 equal to W1, and that is equal to 1 0 1 1. Now we have to find a vector W2 that is orthogonal to W1. So to find that, I have an equation that says that V2 minus W1 V2 minus V2 transpose times V1 over V1 transpose V1 times V1. So if you do this, you will get a orthogonal vector for W1. So in this case, let's do this one. So W2 is basically this value 3 0 1 minus 1, 3 0 1 minus 1, and what I have to do is I have to subtract this transpose. So first of all I have to transpose this one. So if I transpose this value, this will become 3 0 1 minus 1, and if I take v1 is 1 0 1 1 1 0 1 1, and in the bottom we are going to have v1 transpose. V1 transpose is basically is going to be something like this: 1 0 1 1, then v1 1 0 1 1 multiply by 1 0 1 1. Now let's do this one. So 3 0 1 minus 1 minus, if I so this is a 1 by 4 matrix, this is 4 by 1 matrix. So when we multiply 1 by 1, so it means it's a number. So 3 times 3 is 3, 0 times 0 is 0, 1 times 1 is 1, so 3 plus 1 is 4, minus 1 times 1 is 1, 4 minus 1 is 3, so 3 on top. So this is also 1 times 1 by 4 matrix, 4 by 1. If I multiply, I will get a 1 by 1, it's a number. So in this case, 1 times 1 is only 1, 0 times 0 is 0, 1 times 1 1, so 1 plus 1 is 2, so 1 times 1 1, 2 plus 1 is only 3. And then 1 0 1 1. So this is basically 1 multiplied by this one is going to be itself. So it's going to be 3 0 1 minus 1 minus 1 0 1 1. So if I subtract this one, I will get 2 0 1 minus 1 0, then minus 1 is going to be 2 minus 2. So this is the orthogonal vector for W1. So W1, W2 are orthogonal, and we can say therefore orthogonal basis are 1 0 1 1 comma 2 0 0 minus 2. So these two are orthogonal basis of S. And then the third question, C part is asking find an orthonormal basis. It's same thing, but in this case what we have to do, we have to divide this one by its magnitude. So if I find magnitude is basically square and square root of this one. So it's going to be 1 square, 1 square, 1 square, and if you square root, it's going to be root 3. I have to divide this one by root 3. So I can write this one as C. So orthonormal basis, orthonormal basis of S equal to so I found 1 square, 1 square, 1 square, root 3. So it's going to be 1 over root 3 times 1 0 1 1 comma 2 square minus 2 square, 4 plus 4 8. So 1 over root 8 times 2 0 0 minus 2. So these are my two orthonormal basis of S, and that's how is, so this is an orthonormal basis of S, and that's how we do this question. I hope you guys like this video. See you next time.